Hello, this is Rohit. So today I'm going to solve the question, basically a third one of BitMasks question, and the question is sum in binary tree. So this is a basically tree question, but uh, there is no need to create a tree and traversal and these things. So we can solve. Let's see what question says. So one year really likes math, and one day when he was solving another math problem, he come up with a interesting tree. And this tree is built as follows. So initially the tree has one vertex with number one and the root of the tree. Then one adds two children to it, assigning them occurrence number, consecutive numbers two and three respectively. And after he will add children to the vertices in increasing order and their numbers starting from 2 assigning to the other, so on. So you can see, you can observe that from figure. First, always the root node is 1, then we have 2 3, then we assign 4 5 6 7 8 9 10 11 12 13 14 15, like that. So now what is the question says, Vanya wondered that the sum of the vertex number on the path from the vertex with number 1 to the vertex with the number n in such a tree is equals to, means if they give input something like 11, so from 11 to 1 you can see there is a path from 11 to 5 5 to 2 and 2 to 1. So we have to find the sum of this path, sum of this path. If they give something like 13, then we have to find the sum of all the node value, that is 13 plus 6 plus 3 plus 1. So how we can solve this question? And you can see the value of n, range of n from 1 to 10 raised to the power 16. So it's a huge value. So let's understand. If let's say example we are taking 3. So if we take 3, so this is 1 2 3, where then so our answer is 3 plus 1 is 4. So 3 plus 1 is 4. Now we have 10. So you can see 10 is here. So from 10 we will add 10 plus 5 plus 2 plus 1. So this path is our answers, and 10 plus 5 15 plus 2 17 plus 1 18. So this is the intuition how we can solve. So you can observe something. This is 10 and the half of the 10 is 5. Half of the 5 is 2.5, but we will take a floor value, that is 2. So 2, again we divide 2 by 2, it will be 1 and then 0. So for a given number we repeatedly divide until the number will be 0. This is the main intuition about this question, right? Okay, so let's solve this. So we have to take one input n and test cases are there. So here test case n. Okay, I think there is no need of this, so just remove this. So what we will do, instead of n we can take p, it will be meaningful. Okay, and now here we have n, so n will be, we have to take long. Okay, and just see the constraints once again. Yeah, we have to take long. So let's say this is n, then we will take input n, and we have to take counter as well. So long count is equals to 0, and while n is not 0, until what we will do, we just add. So initially when we are starting from 10, so we have to add 10, then we have to add 5, and first we add the original number, then we add the half of it, then we will add the half of it, and so on, right? So first thing, okay, instead of taking count, we will take a sum basically. So what we will do, we add that number first. So sum plus is equals to, sum plus is equals to basically n, and then we divide the n. So n divide by 2 and so on itself. it will give the output, and we will say out some. So let's run and say it's working or not. So test cases are these. So our answer is 4, 18, 71, 1, 1999 and something like this. So you can see these are the same question. So this is not a basically tree question, but you have to observe. This is not exactly tree. Okay. So let's copy this code and just submit it. So I hope you understand. So let's refresh. I think, yeah, it is submitted. So this is the intuition of that question. In the next video, I will come with the next question. For the time being, till now, you can try to solve the next question.